Hello, physics fans. Mr. Russo. So we've made it to Unit 7, Energy, and we're talking about collisions. And I just wanted to give you a brief tutorial before you started a simulated lab, on collisions with this Phet interactive. Because there's some things here little nuances that took a while for me to learn. So, all right. So when you open it up, you can see there's toolbox here. You have control over whether you turn things on or off, right? And we'll go through those. And basically, you can adjust the mass of the two balls. And I'm going to throw down the values just so you can see that they've picked a value and you have no control over that. Ball 1 is traveling at 1 meter per second and ball 2 is traveling at a half a meter per second. But you can vary the mass. All right. And so varying the mass is simple as dragging. It is very difficult to get them exact, mouse skills, but you can click on it and go 1.5 and make them equal if you want. All right. And so we can just turn those values off. I don't want to be distracted. Just hit play. So what did we see? What did we learn? I don't know, maybe nothing. But that's what's cool about this. And so the experiment's still running, so I can just go replay that. And I can throw on my velocity vectors, and you can see that ball 2 has about half the size of the velocity of ball 1, and they're going to hit each other again. Oh, and then we can see that they change direction. So I can also put on their values. That's up to you. But we can put the momentum on there. And let's hit return balls. All right, so as discussed, momentum, rho, is mass times velocity. Right? So back to Newton's laws, right? Impulse and momentum. He was looking at how much force does it take to make these things happen, and now we're just digging in a little differently. All right, so let's see what happens to the momentum. So notice how the momentum vectors are laying with the velocity vectors. I think that's important. All right, this is how, and so this little thing right here, boom, I like that. All right, so I can see that the momentum of ball 1, well, that's currently, what happens when I return them? Oh, look at that. So right now, ball 1, because it's going twice as fast, has twice as much momentum going in that direction. Ball 2 has that much, and the vector sum is shown right there as total. So interesting, right? So let's just play it again. Oh, and see how it switches, but still the total momentum stayed the same, even though the balls changed direction. So that's interesting. And then I also noticed, who knows if we've talked about elastic or inelastic collisions at this point, but you can see that I can change the elasticity. And so let's just swing it all the way over to inelastic and return and try that again. So you can see the difference between an elastic and an inelastic collision. Oh, they stuck together. A little learning may have occurred. All right, so I'm just going to put that back to elastic collisions. That's where I want to start this. And so you can, I think this is an interesting one. Watch that center of mass. I don't need the momentum on there. Return, start again. Watch the center of mass. So this X is representing the center of mass of the entire system. Interesting. The center of mass of the system continues traveling to the right. It matches that total momentum of the system. This is laying some vector stuff and some math stuff on there and helping me get a different understanding of the world. So this is how you play. Hope that was interesting. All right, so make sure you open that momentum diagram. We will work you through turning these things on and off and what to see for some guided play. All right, hopefully that helped, and we'll see you soon.